All right, so good morning, everyone, and hopefully, I want to make this video just to go over your quiz or your assignment from last week. So, if we're looking at question number one, when static electricity occurs, this is caused by the movement of what? And that is going to be the movement of electrons. Remember, electrons are the only substance that can move. So, when you're dealing with friction or with other charges per se, electrons are the only actual thing that gets moved. Now, the object might have different charges, positive or negative, but the only thing that truly moves is going to be electrons. So we look down here, true or false. Electrostatic force works only when two particles touch each other. Therefore, electrostatic force is considered not a is considered an at a distance force. The answer to this is actually false. So electrostatic force is considered at a distance force. Remember, the two things do not have to be touching. So if we think about this problem right here, the balloon is not touching the stream of water, and therefore it's still affecting the stream of water because the forces don't have to be touching. But if they move close enough to one another, yes, there is a force that can happen. Okay. All right. So when working with magnets, they are able to attract and repel each other because the electrons that swirl around the magnets. That is, in fact, true. All right. So if we look here, I'm excited, young Mr. White, looking at this picture, right? So here, what conclusions can we make? Well, I didn't give you a lot of information with this picture, but the big thing is the hair going on right here. So with this hair, we can see that each one of these strands of hair are repelling one another. So somehow, some way, we know that this hair got charged. So many of you talked about using a friction tool or touching something, but what we can assume is that all of the hair is either positive or all of the hair is either negative. So it's either positive or it's going to be negative because it's all repelling one another. So that must mean that the charges are all the same. So with this picture here, you didn't have to give a massive explanation or conclusion, but my biggest thing was to show you that clearly each one of these strands of hair all have the same charge because they're repelling each other. All right, here we go. Step three, charging. So with this one, you have a positively charged foam board down here. Now, with this positively charged foam board, that's going to start to attract all of the electrons down here. So all the electrons are going to start to gather at this part of the pi tin. Now, they're not going to transfer because see the space here? They're not touching. So the electrons are going to gather in the space down here, leaving the top part of this tin up here is all going to be positive. So if you have a bunch of electrons that are transferring and traveling to the bottom, that means the top of this is all going to be positive. So everything in this statement the student says is true except for this part here. Then once the person touches the pi tin, the electrons jump from the pi tin to the hand. Now, we know here the top of this is positive. So we know that if there is contact that's made, the only thing that can move are negative electrons. And these positive protons aren't going to move anywhere, this positive charge. So actually, you're going to have these negative electrons on this hand here, and they are going to move to the pi tin. So the negative electrons here are all going to jump to the pi tin because there is contact being made. So the part that is incorrect about this statement is the last sentence. Okay, here. So based on this diagram, what force exists between these two particles? So we have positively charged particle, negative charged particle. So gravity, nope. Electricity, nope. Magnetism, nope. But we have an electrostatic force. So this is the most correct answer. It is not magnetism. Remember, only with magnetic materials are you going to see a magnetic force. But when you have charged particles, positively, negatively charged particles, the force is going to be electrostatic. Okay, so what are the two main forces we worked with? Electrostatic and magnetism. Explain in one sense how they are different and how they are the same. So, number one, magnetism, right? Magnetism itself only affects magnetic propertied objects like metals. Now, not all metals, but iron, cobalt, nickel, all of those are natural magnets in and of themselves. How are they the same though? They both work with this idea of transferring of electrons. So with magnets, we know that we have a bunch of electrons that swirl around a magnet. And also with electrostatic force, you're going to be dealing with this electrons, and the force itself is going to transfer to and move towards the electron, which is nice. So here, being people claim that electricity and magnetism are the same and they're very similar, this is because they both deal with the transferring and moving of electrons. If electricity is flowing, a magnetic field is created. Now, magnetism itself doesn't, they're always going to have those swirling electrons, but as soon as electricity is flowing or is generated, a magnetic field is also created. It could be on a wire. So if you've ever used like your iPad, you might notice that sometimes like a paper clip might stick to it. It's because there's an electric field or electricity is flowing inside the iPad, and parts of the iPad may become magnetic at certain points. So here, when two particles are near one another, the direction of the electrostatic force that will travel from the negatively charged particle to the positive, that is false. It will always be from the positive to the negative. So you're always going to be seeing the flow of electrons, or my bad, not flow of electrons, the actual direction of the force going to the negatively charged particle. Okay, so if we keep going, polarization. So if we look here, positive, what side of the sphere would the electrons gather on? So you bring a positively charged object here, all the electrons are going to start to pool over on the left side because remember, opposites are attracted to one another. They're not going to make the jump, but since it's close, all the electrons are going to start to gather over here. So if we look at our choices, electrons jump off. Nope. Electrons gather on the left side of the sphere because they're repelled from the protons on the right side of the sphere. That's not true. The electrons will gather on the right side. Not true. The electrons gather on the left side of the sphere because they're attracted to the positively charged balloon. Ding, ding, ding. We have our answer for D. All right, based on this picture here, there are two particles. Between the particles, there is force. What direction is it going? If you said to the right, if you said, people were saying like cardinal directions, like east. But really, if as long as you put that it was moving towards the negatively charged particle, you got credit. All right, this one here. We know that a balloon itself can collect charges. So in this case, we know that the balloon can collect electrons. So all of a sudden, you have a bunch of electrons that are gathering on this part of the balloon. What happens is when the water comes out of the tap, so our balloon in this case is negative. And when you have the water that comes out of the tap, it's actually slightly positive because there is, so what happens is really the positively charged molecules, in this case, flip when they get out of the stream. It's attracted to the negatively charged balloon. So this was all in a video I showed you. I think it was week 2 of online learning. But if you want to go back to week 2, there's a video that describes that whole process. But we can for sure tell, in this case, the water is attracting towards, they must have opposite charges. A lot of people were making the confusion of like positive electrons. Remember, electrons can never be positive. They can only be negative, and they're attracted, in this case. They're collecting on this balloon, so it makes the balloon negative. And then when the water comes out, it's slightly positive, and so it gets attracted to the balloon. All right, this was the last one. And you can see here there's a bunch of different words, and they're all meant to throw you off. Really, you just need a few of these words. So, one day on a dry winter morning, you were walking back to your room to crawl into bed. As you were walking down the carpet, you were wearing socks. As your socks rubbed on the carpet, you became, in this case, positively charged. So, if your socks are rubbing on the carpet, remember the only thing that you can lose are electrons. So if you lose electrons, you become positively charged. And that then sets up the rest of the problem. So if you become positively charged, you reach the bedroom door, you reach your hand out to touch the doorknob, and what is going to transfer? Remember, the only thing that can transfer are electrons. So I'm just going to draw a little arrow here. So the electrons are the only thing that can transfer to you, remember. Then the electrons transfer to your hand because why? The doorknob itself was positive, or my bad, negatively charged. My bad, sorry. Remember, the doorknob has a bunch of electrons on it right here. So that means the doorknob itself was negatively charged. So that's going to be jumping into spot number 3. Remember, opposites attract. You are positive. The doorknob itself is negative, and eventually what happened was, and then you. So one more time. Once you reach the bedroom door, you reached your hand out, touch the doorknob. The electrons transferred to your hand from the doorknob because it was negatively charged, and you were positively charged. So we'll just draw another arrow. As you notice, positively was listed twice. Here. So this is the correct order of the problem. So remember, electrons are the only thing that can move. If you lose electrons, you become positive. And then if you're positive, you are going to attract more electrons. That's why you get zapped. So hopefully this video cleared some things up. Thanks for watching.